So in this video, we are essentially going to take everything that we've had so far in 2D vectors, and we're going to extend them into three-dimensional. So all the premise and all the kind of understanding that we've already got is just going to be extended here. And all we're going to do is we're going to add on one extra dimension. And again, that is called the Z direction. Now, just like 3D coordinates, it's just an extra value on at the end. So for our vectors, it just goes in at the bottom. So we've got our journey in the X direction, our journey in the Y, and then that Z value goes on at the end. And again, our diagram still looks the same. So you still have X, Y going left and right, sorry, X going left and right, Y going forwards and back, and again, Z goes up the way. Now, what we're going to do is we're essentially going to look at the adding and subtracting element first. We'll then go on to look at magnitude, and then we will finish off looking a little bit at 3D vector journeys. So u plus v, we answer it still in the same way. 4, 2, and 0. Add the vector v, which is, let me just double check, 7, 7, negative 2, and 1. So we still start with the x values. 4 add 7 is 11. 2 add negative 2 is 0. 0 add 1 is 1. And so that's the vector u plus v. We still multiply by scalar in the same way. So 5 lots of u, so use the vector 4, 2, and 0. We multiply each value by 5. So 5 times 4 is 20. 5 times 2 is 10. 5 times 0 stays as 0. Now, the magnitude. The magnitude works in a very similar way, okay? It's still the square root. And your v here is, so it's 7, negative 2, and 1. So I'm just going to rewrite the vectors down here so I can see them. So u is 4, 2, 0. And v was the vector 7, negative 2, and 1. That's just so I don't need to go moving up all the time. So the vector v, we take the first value, square it, and we add the second value squared. And that z value, we just do the exact same thing. We square it and we add it on. So if it's a three-dimensional vector that you're trying to work out the magnitude of, you're going to have three things adding together that are all squared. If it's two-dimensional, you're just going to have two things. And just like in the 2D, if it's coming up in a calculator question, you can just type it all straight into your calculator to work it out. If it's coming up in a non-calc, it might be something where you're going to be getting a third answer. Okay, so if I type that all into my calculator, so it's going to be the square root of 7 squared plus, and again, always recommend putting the negative 2 in brackets. Negative 2 all squared plus 1 squared and it will come out as 7.348 ... which is 7.35, and I've rounded that to 2 decimal places. Okay, you get to choose what you round to. I always recommend 2 decimal places if the question doesn't say. Again, make sure you're always checking to see what the question says first. And again, they might combine the two things together. So 2u plus v and the magnitude of that. So let's start with 2u plus v. Now that's going to be 2 lots of 4, 2, and 0 plus v, which is 7 minus 2 and 1. So that's going to be 8, 4, 0. Add 7 minus 2 and 1. That's not changing. So when I add these together, I'm going to get 15. 4 add negative 2, so adding a negative, I'm taking away, that's 2. Oh, apologies. That's going to be 2. 0 add 1 is 1. So when I'm working out the magnitude of 2u plus v, now I know it's the magnitude because they've put those two vertical lines on either side, it will be the square root of 15 squared, add 2 squared, add 1 squared, which will come out as squared, add 2 squared, add 1 squared, 15.165 ... That's my unrounded value, and I'm rounding to 2 decimal places, so 15.17 to 2 decimal places. Now, the last thing that we haven't looked at here is our vector journeys. Now, there hasn't been one of these come up in 3 dimensions in Nat5 yet. So this is a question from a higher past paper. So some of vectors used to be part of higher, or all of vectors used to be part of higher, and some has been brought down into the National 5. Of course, this is part of it, but this is very much at the top end of that. Okay, but I wanted to include it in this video just so you have an understanding of it. It works in the same way as 2-dimensional vectors. You're still going to have a starting point and you're still going to have an end point. So we're trying to get the vector r to p. So we're starting down here in the bottom corner at r, and we're trying to get to the top p. Now, one of the common mistakes with this is people would say, oh, well, that's just the vector h. Okay, h takes me from the top to the bottom. But remember, vectors have a direction. So that's heading from kind of where you are, away from you, and up. If you were to apply that from r, in fact, what I can do is I can do a little trick. I can copy and paste that. Let's clone it. If I was to start and do that from r, I'd head out there. I would head away from the top of it. Okay, so that vector h only takes you to p from t. Okay, from r it takes you away, from s it takes you away, and from q it takes you away. So it doesn't work. Okay, but one thing that we can tell from that is, well, if I get to t, I can get to p. So let's work on trying to get to t then. So I know that's f, so I can use that. And I know that that one there, g, is the same as this one here. So let's write this out. I'm starting at r. So r to p is going to be the same as going from r to s, and then going from s to t, and then going from t to p. Now, r to s, I know is the same as that q to t. They're the same. So r to s is the same as q to t. S to t, well, I know that that's f, so I can just leave that alone. And I know what t to p is. So q to t, that's minus g. S to t, that's minus f. So I shouldn't say plus, I should say minus there, apologies. So I'm going negative f direction. And then I'm heading in a positive h direction. So what I'm saying is I'm heading minus g, so I'm heading down here. Let's use another color. So minus g, minus f, positive h. Now, there is one last little thing, and it's a little thing about convention. In maths, we don't like to have that negative at the front there. We don't like starting something with a negative if we can avoid it. And we've got this plus h here. So it's conventional. Now, what I mean by that is later on in maths, what they'll start picking up, and for those of you that go on to do higher, advanced higher, and beyond, we would try and write this without a negative at the start. Okay, you're not going to lose marks for doing it in National 5. For those of you that want to, it's kind of the where you're heading with it later on, we would put that positive h at the start. And how we would write it is h minus g minus f. So I'll stress you're not going to lose marks if you don't change that around. Okay, but it's just good mathematics to do it. It's a convention not to have a negative at the start. So that covers pretty much all of the 3D vectors. As always, you can ask for help in the assignment question section if there's anything, or you can rewatch the video at any point.